I had my brother's call this, I would appreciate that. But I don't want men's cheese. Would you like 15 cents?
No, thank you.
Ah,
I appreciate it though.
Evie?
You can go buy yourself something nice. Hey, today is, I think, what they call on the calendar. I really don't know this, but I think it's called like leap day. You only get February 29th once every 4 years. So you will not see the date February 29th again until 2028, at which point some of you will be like 21, 20, 18 years old. It depends how old you are now. So anyways, today's like a bonus day. I know, right? You get ripped off.
Like I had 13 birthdays. And I was born on a weekday. I'd be 60 years old.
I was about to give you guys a practice quiz today, and then I looked at my practice quiz and I went, "Oy, geez." And honestly, I wasn't really sure if we needed this for a day, but I thought, what a nice thing to do on a Thursday. So we're gonna make this official. Thank you. I'll turn that on. We're gonna make it official and actually do a lesson on this one little piece. After this, you will be ready to get going towards a quiz. I'm going to leave out the part about log expansions. I'm just going to take it off your quiz this year. So, yeah, you know how we condense? You know how we take like log of A minus log of B and we make it into log of A over B? Like you should be good at that. You can go backwards too. So like if I give you like log of 5x, you could break it into log of 5 plus log of x. Like you can do condensing, but backwards. It's called an expansion. But I really don't think, like if it happens to come up, we'll just address it right there on the spot. But we're going to leave that out. So yeah, we have more log equations today. And I know it's like all you've been doing, but there's one more little flavor of them that we just want to run through today. This won't take long. The only people for whom this will take a while are the people who struggle with like factoring, basic like polynomial stuff. So here we just got 4 examples. Let's knock them out. So we got log base x plus 5 of the quantity 2x squared minus 7x plus 7. And that equals 2. So delta math very specifically refers to these as like quadratics. Like, and I can tell you that every problem in today's assignment is going to be a quadratic. They won't all spawn exactly the same way as this one does, but they'll all, in the end, once you water cycle them out and convert them over, then they'll all be quadratics, like 100% today. So having said that, let's hit it. There's not any prep work today, so that stuff you started to get used to where you have to like add a 5 across and then divide by -4. The logs, I believe, are all already by themselves. So these ones we just hop right in and hit them with the conversion. So on this one, we're going to take our base here, and of course, we're going to raise it to the power of 2. And the answer is going to then equal, like that never will change. Base to the log equals argument over and over and over. So fundamentally, and I don't know, you get like offended if you miss this, but by now we should probably know what is x plus 5 squared. And it's not x squared plus 25, so don't say that. Anyone want to take a stab at that? Nice job, dude. And I'll run through that with you again just to refresh you on how we did that. But remember, that's the whole square multiply double thing. So just real quickly off to the side here, I'll switch colors in case you're rusty. And I probably won't go through this with you every time because good job there, Coop. If you take x plus 5 and square it, you have options as always. You can write it out old school, which that's going to make your assignment take a lot longer, right? But you could, or you could just remember, again, square, multiply doubles. So remember, we square the x and we get x squared. We square the 5 and we get 25. But then in the middle, when you multiply the red and the purple together, you get 5x, you double that, and that's where the 10x comes from, right? I feel like that should probably be something that's in our toolbox by now. So that's what happens when you start the first part of the water cycle, is when you're actually squaring a binomial. So there's a little bit of math like before we get to the other math. And this will just keep happening to you today. I just thought, let's just take a day and do this. No harm here. And then we'll practice quiz on Monday. So it's a quadratic. So our thinking is let's get all the stuff to one side. Which side should we go to the right or to the left? Yeah, definitely to the right in this case. So that's going to leave us with 1x squared left over. How many x's will we have? Negative 17 for sure. Right, because we're subtracting the 10x across. And then what will our constant term be? Minus 18. Good. And that is going to equal 0. So, like I said, if you struggle still with factoring, man, I hope you don't, I was your Algebra 1 teacher, and I'm your Algebra 2 teacher, and I think it's reasonable for me to say, I hope you don't leave your time with me here in a couple months and say, I still don't know how to factor. Like that would really suck. So when we factor this down, fundamentally, we know that there's one positive and one negative because they multiply to make negative 18. And then what numbers are we looking for here? I mean, there's 6 and 3, 2 and 9, but the ones we want are not those. What do we want?
118.
We want 1 times 18 because we want to make sure that when we add the two middles together that they make negative 17. So you can't accomplish that with 2s and 9s and 3s and 6s, but you can with these. So what are our solutions?
1 equals 18.
Right. And so remember, we're not ready to type this in yet. It just takes just a few seconds to put them back in and make sure that no laws are being broken. So let's just do them one at a time. So initially, we have two things now of concern. The first thing that should be of concern is this base. Like we don't want the base. If you remember the properties of logs, we talked, it's been such a long time, like weeks, but remember the log base cannot be what? Yeah, what else? 0, what else? There is something else. With the argument, you can say it can't be 0 and it can't be negative. I believe that's what we settled on there, but the base has 3 restrictions. It can't be negative, it can't be 0. What else can't the base be? And if you don't have it as you're thumbing back through your notes, add it in. It can't be 1, right? So those are the 3 things to consider when we're checking our solutions is the base of the log cannot come out negative, it cannot come out to 0, and it cannot come out to 1. Because like a log base 1 of 4, you'd go, well, that's not possible. Like it can't raise 1 to some power and make 4. So we have a lot on our plate here, but it doesn't take long. Like once you get the flow, so let's take -1 and put it right here. Are we good there? Yeah, that's fine. And then the other solution was 11, I think, or 8, I wasn't even close. 18. Put 18 in there, and you're like, we're good. So so both answers passed the base test, and now we have to pass them through the argument test. And again, just put them in place of the x's. So now you're going to have these green arrows up here, and let's just start with -1, right? Can you see right away that that's going to come out massively positive?
Yeah.
Like what's -1 squared?
1.
2 times 1 is 2. But the best part is the only chance this had of going negative is the -7x. But if you feed it a -1, it becomes +7. And you're like positive, plus positive, plus positive. No worries there. And then our other answer is 18. And that one might be of some concern. But I maintain this. If you put 18 where this big, fat yellow arrow is, this is the important one that I want to talk about. Do you guys know what 18 squared is? It is. It's like 324. Yeah, so I think it's 324. And then if you take 324 times 2, you're like 648. And there's not going to be enough negativity in that wimpy little 7 times 18 to even come close to that. So you don't have to finish the math always just to be able to say that we're good. So these are both valid solutions here. So got it? So you would type them both in. And this is going to be one of those delta assignments where you have to like hit the little add answer box or hit the comma or whatever, however you do that. So good there.
Delta.
Neither one of them is undefined. Like when we put negative, but -1 is not the base. -1 is if we put it in place of x, the base comes out to 4. So it's not about what the answers are, it's about what they caused to happen in the original problem. All right. All right, let's go again. So hit it with the conversion, the water cycle. So my first purple arrow is going to go from here to here. And I go, oh, what a nice thing if we could just start getting these quickly. What is 2x minus 2 squared? It is not whoa. Ay, ay, ay.
2x squared.
Mm-mm.
4 squared minus 8x plus 4 equals 6 squared minus 1.
So that's the important part. Speedy Pants over there went a little further than I wanted, but are we okay with the fact that that's what happens when you square 2x minus 2? Square, square, multiply, double. I really would like it if you'd ask right now if you don't know how I'm doing that, because the fact that I think you should be good at it doesn't mean that you're like a bad person if you ask. Are we all quick and clear on that? Want some help with that? When I square it, I take 2x minus 2. And I take this, what was that little, did you see that guy? I had like a little alien invader. Oh, get out, stop. Holy smokers. All right, Tristan, my explanation's always, it's never going to change. I'm not going to take shortcuts. It is what it is. Take that red thing and square it. What do you get? You get 4x squared, right? Take this purple thing and square it. What do you get? And then take the red thing and the purple thing and multiply them together. What do you get? Negative 4x. Then double that. What do you get? That's why I keep that expression, square, square, multiply, double, square, square, multiply, double. That process is never going to be any different. Okay. It's not about multiplying by twos. It's about square, square, multiply, double. Like, got it? 100% till the end of time. Yeah. Okay, you sure? All right. And then, yeah, like Speedy Pants told us, then we're going to set this equal to 3x squared minus 11. And yet again, we have a quadratic. And so x squared all this stuff should go to what side? Left for sure this time, because I want to keep positivity on my quadratic term. So I'm going to get 1x squared minus 8x plus 15. And then from here, what are the factors? You're going to have to do a little bit better than that, like give me a little more specificity. So x minus 3 times x minus 5, good. And that then gives us solutions of x equals 3 or x equals 5. So our answers that we kind of have hovering there right now are 3 and 5. And if you put them both back in here, don't make this take as long as it did the first time. Just be quick and efficient. Sometimes they will fail, sometimes they will not. You take 3, put it in, you go check, that's good, check, that's good. 3 squared, 9, 3, 27, you're good. And then check 5, and 5's going to work even better than 3 did. Like if 3 can torch through this and say, I didn't make any bad stuff, well, 5's going to do even better, right? He's bigger, and this is all big, more sensitive positive stuff, right? More positive, yeah. So those both pass. I do want, hi, bud, what's up? If we tried them both, we would just write no solution. Like if both answers, I don't think you're going to get any today. I don't think where that's going to happen. But you would just put no solution. think. But again, I've said that before, but what happens is when I click through the delta, I click 15 or 20 times, but probability says that that's still a small sample size. Maybe if I'd clicked 22 times, then I would have found one that's like, I just click a lot to try to get an idea as to what the program has in store for you. And I didn't get any that had no solution. But that doesn't mean that they're not in there. It just means I didn't get any. So they're probably not in there. The log with the base of negative 2x plus 2 of the quantity 2x squared minus 10x plus 4 equals, you guessed it, 2. And why do I keep putting that 2 on the right side? Because I can square it, right? That's where the whole quadratic stuff is coming from. So this is a pretty specific little corner of the logarithm equation world. So really my primary concern, oddly enough, is this step. And I would like you not to say it out loud. Let's give everyone a chance to make sure that we're all solid on that first squaring step. Okay. So remember, square, write it down, square, leave a space, write it down, then multiply double. Good. So if I were doing this, which I guess I'm about to, I would square the negative 2x and I would get 4x squared. I would square the 2 and I'd get 4, but I would leave a space. And then when I multiply the negative 2x and the 2 together, I get negative 4x. I would double it and get negative 8x, which is kind of funny that it's the same as the last one. Which is the negative just switch spots, right? And then that's going to be equal to 2x squared minus 10x plus 4. So which side should all of our stuff go to? So we're going to get 2x squared. How many x's? How many constants? Like what's my number? 0. Yeah, that's twice you tried to pull that on me today. Okay, remember when you're moving them across equals, you got to change the sign. Okay, so 0 it is. So I didn't put anything after the 2x squared plus 2x because the 4 is going to come across and just wipe it out. So this is a unique little quadratic. Do you guys remember by chance? This is not conventional double parenthesis factoring like you're used to. You remember how to factor out something like this? There's something called the GCF. And the trouble with quadratics like this is they're so infrequent that we forget them. Like we all know how to factor when there's 3 terms. We're like robots. We go parentheses, parentheses, x, like autopilot kicks in. But then we get a quadratic like this that's missing this term quite conspicuously right there. And I'm just telling you the strategy you should use with quadratics like this. If it has the quadratic term and it has the x, the linear term, your go-to should be pull out the greatest common factor. So in this case, what's the GCF of these 2 terms? 2x, which leaves behind x plus 1. Got it? You sure you got that? And then if I look at the red factor, I say to myself, you do produce a solution. Remember, you are x equals 0. That's what I get from you. If you're a variable GCF, you give me an answer of 0. Thank you very much. And then the white factor gives me an answer of x equals negative 1. So much of algebra is just like make it equal 0, make it like that's the goal with factoring is make them equal 0. You made these beautiful factors, now set the things equal to 0, right? That's the plan. So the answers are at this point 0 and negative 1. So we're going to go back to the beginning of the problem and we're going to take them for a quick spin. So let's do 0 first. If you put 0 there, anything stand out? You get 0 for this part, but what's 0 plus 2? So we're fine there. Put 0 here and here. What do you get? We're fine. So the argument came out positive. The logarithm came out to not equal a negative or a 0 or a 1. Passed both tests. So you can put a box around 0 and say, you're my guy. And then we also have to test the other one, which was -1. And I would say the same things are going to happen. Go to those red arrows and just pop a -1 in there, and you're going to see all good things. -2 times -1 is 2, plus 2 is check, good. And then put the -1, and you're just like positive, 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 pass. So we've had 3 problems now where both answers have passed both tests, which leads me to the 4th example. And if you know me at all, you probably know that something might change here. So let's do it, and then we'll get to work. So for this one, we have the log with the base of 3x. And the argument is 10x squared minus 11x minus 12. And that's equal to, you guessed it, 2. So we start with the conversion, this to the this. What does that equal? What is 3x squared? It is 9x squared. Good job. Yeah, it's not a binomial, so you don't have to square, multiply, double. You just square the 3 and the x. Oh, good. So, and then we set that equal to the argument 10x squared. And once we're out of the land of logs, we don't really have to come back and talk about this top line until we're done here in a couple of minutes. And then we take our answers, and that's where we always go back to, is like, you know, when there are logs, we want to see if we break any logs. So we can leave the land of logs now and just go back to like September, solving a quadratic equation. Let's move all of our stuff to the right. And it's not because it's less work, it's just because that's the way this particular problem falls. So if I subtract 9x squareds, I get just x squared. And there it is, ready to go. So my factors will be, this is just normal factoring, right? You got all 3 terms. Yeah, we've got a 12 and a 1 in there somewhere. So we got x plus minus, give the beef to the negative and the wimpiness to the positive. We want to make sure that the power struggle ends with a negative, right? So plus wimpy 1 minus beefy 12. What are my solutions? So x equals -1 and x equals +12. And it's that time again where we take those answers before we just want to hit them in, but we don't type them in yet because we think that maybe, you know, hint, something bad might happen. So let's start with -1. If we put -1 right there, what do we get? That breaks a law, right? And that's just in our list. Like, I think we had 5 things that we wound up having to know. Like, there's 2 things that the argument can't be, right? Arguments cannot be 0 or negative. And there's 3 things that the base cannot be, 0, negative, or 1. And if all 5 considerations are made, then he fails, right? So he broke the law. So x equals -1. While we didn't do anything bad to obtain it, it's not a valid solution. So we just omit it. And then we try 12. And if you put 12 where the little red arrow is pointing up there, that's obviously fine. And then if you put 12 where these other red arrows are pointing, again, I look at the logic of this and I say, all right, 12 squared is 144, right? But if you multiply it by 10, what do you get? You get 1440. Like, that's a lot. That's a lot. And there's no way that if I put my little wimpy 12 here, that 11 times 12 can even hold a candle to 1,440. So like that first term is said, I am super positive, hear me roar. There's not enough negativity coming down the pipeline here, right? So 12's fine. He passes. You can do all the math if you want, but it's like, it's obviously going to pass. So that would be one where you'd only type in one number as a solution. Do you guys have any questions on this? This will be it as far as direct instruction is concerned. Monday, I'll have a practice quiz for you, and then we'll be in mode, like, let's head to the quiz. So that's that. So it's on Delta. You got about 15 minutes. Let's see how much we can knock out. I might have put too many problems in. I don't know. We'll just play it by ear. We'll see. I'll leave the recording going, and I'll pause it, but in case anyone has any that are, you know, pretty special or cool. So a good question just came up. So you guys might be interested in this. The question was, can I pull a GCF before I factor? And what did you say your quadratic was? Yes, excellent question. I wasn't aware that this would pop up, but here we go. You guys should always pull a GCF if the opportunity arises. By the way, there's no way that you could not, like, you could all factor it like this. But to make it easier, if I take the 2 that I can see and you can see that comes out of all of these, if I pull that 2 out front, I get a simpler version, right? Or you could even think of it as like, because it's equal to 0, you don't even have to keep the 2 around because the equal sign makes it so we can just disappear things. So like I could just divide everything by 2 and just get x squared minus 1x minus 2. Excellent question. So remember with GCFs, if you have an equal sign, you can just divide and it goes away. If it's just factoring for the sake of factoring, then your GCF has to stick around. What I just said applies only if the GCF is a number. If it's got a variable, it never goes away. Good question.